Alrighty, so let's do some practice questions pertaining to the vertex form of a quadratic. So let's get right down to business here. What is the equation for the graph shown? All right, so they gave us a bunch of samples and we could do comparing, but let's just go and see if we can figure out what this equation is first of all. All right, so, oops, jump the page. If we're going to write the equation for this, we know we're going to have y equals, in vertex form, a outside of x minus h squared plus k. And that should be a k. And it's the vertex that gives us the values of h and k. So let's go there first. This vertex has coordinates of -3 for x and -4 for y. So when I fill those into my equation, I should have y equals a outside of x minus h will be +3 squared plus k, which in this case will be plus -4, so -4. All right, so which one of these equations? Oh wait, we've got to deal with this a business. But they've all got the same value for a. They're all 1s. So that's not going to make a difference. So a is equal to 1 whatever way we dice this one. So which one of those equations matches this? +3 for h and -4 outside there. There we go. That's that one. Okay, looks like all the signs are just trying to play tricks with which way you know things go, up or down, left or right. Next one, determine the axis of symmetry, okay, the vertex, and the domain and range, okay, for the parabola whose equation is given by that. So let's see what we got here. So axis of symmetry first, and the axis of symmetry just occurs, same as the x-coordinate of the vertex, and that's the value of h, and so we change the sign, that'll be at -5. That was easy. So then our vertex here is going to have coordinates of hk, so that's going to be -5 and -7 for k. So we change the sign on x, we don't change it for y. Alrighty. So from there now we have to find the domain and range. I think I'm going to sketch a graph because that usually helps me get domain and range here. So vertex is 5 units left, -5, and 7 units down, so down here somewhere, -7. And I don't really know much else about this parabola except that this is my axis of symmetry here at -5. But what I do know is if I look at this and I remember the value of a is the same in vertex form as it is in all of the other forms that we had. So this tells me that it would be stretched a little bit, but also, more importantly, that it's got to open upward, thusly. So if this graph opens upward, then I should be in business to write the domain and range. Okay, so the vertex was at -5 and -7. So right here we've got -5, -7. So I'm going to say for my domain, this is a parabola like all others. So I'm going to write both forms of that now. We'll say the set of all values of x that are real. So there's one way to say what the domain is. And the other way would be to say that x can go anywhere from -infinity all the way to +infinity if we write that in interval notation. Then we'll write the range, and that's always a bit trickier for parabolas. It's not too bad. So we'll say we've got all y values that are real, and they have to be numbers that are above or equal to -7. So we're going to say y is greater than or equal to -7. Alrighty. So then if I'm going to write that in interval notation, I'll say I want y to be an element of the interval that starts at -7 and goes all the way up to +infinity. We can't include infinity, but we are allowed to touch that vertex, so we got to write that one. Okay, so that's how we solve that problem. Next, the vertex form of a quadratic function is given by that stuff. Yep, saw that already. Parameters h and k, right, we're good with that. Parameter a is the same in all 3 forms, right, so the direction of opening bit was the bit we had to use in there when we went after that domain and range bit. Okay, so that's about it. Covers all the bases. See you next time.